in this section we will be talking about composite functions. Okay, so in functions we learned about a single function, how it is defined. You know that a function relates a set to another set. This is how we do it. We'll write it here. The function relates an element from the set X to an element of the set Y. This is how a function was defined. But in this section we'll look at what happens when several functions are in play. So how we are gonna go about defining it. So before that, let me focus on an application on this. In real life you will come across things like this. Let's say you have several processors. I have named it by F, G and H. You can think of it as function as well. Think of this example as an assembly line. So in an assembly line you start with some parts, then you make them go through a process, and you will get an output which was modified by the process. The input was modified by the process and you will be given an output, and that output will go through another process. Likewise, the input starting material will go through several processes until it is come as a output, the required output. I have shown it here. There will be a process here. You know that when you input something, let's say it is X, because we are only focusing on functions that is relevant to mathematics. Input is X. When the input X goes through the function F, you know from the basics that let's say you have set X and set Y, and these two sets are connected by the function F, right? Let's say an element, simple element, which is the input for function F, is connected to the output through the function. As you can remember, we call this the image on the function, right? F of X, we call it F of X. So what happens when X is inputted through the function F? It will come out as F of X, right? This is the output from this function. Now this output will go through the other process called G, right? So for G, F of X is the input, not X, right? Please note this. For G, function G, the input is this F of X, right? So when the input is X for function F, you wrote it as like this, function, and inside the argument you put the input value, right? Now in this case what happens, can you guess? So when this input now here being F of X, this will go through the function G, and it will come out of as G of, and the input will be F of X. Okay. Now what happens? Now G of F of X will be the input to the function H, right? And it will go out as H of G, sorry, I will write here, H of G of F of X. I think you get the idea how to write this. So when X is the output, when X is the input, the output would be H of G of F of X. So you can think of it as G is eating, F is eating the input X, and G is eating the function F of X, and H is eating the function G of F of X, right? So when you want to now you want to connect the input X to the output, right? How do you do it? That is what we learn on this section under composite functions. So X input is related to the output of H of G of F of X, under these three processes f, g and h, and we write it as like this. We start with the first function f, then put o like 0, then g, then h. This is how we write it. So when we read it, h by g by f, this is how we read it. H of g of f. This is read as h by g by h. Right. This is how you define a composite function of three functions that is involved in this process. Okay, we'll this is just the introduction to the composite function. We'll take each case and see how this is defined. First we will look at two functions, then we can generalize these things for any functions element. Okay, so look at this example. You have a set x, right, set x here and set y. So in this function f will connect set x to set y, right. This is what the function f does. So this is what we have depicted here, right. F connect x to y. What about function g? G will connect set y to set z, right, z. It will connect y to z. Now if I want to find a function which connects set x to set z, how do you write it, right? So we have to find this function. So what will connect set x to set z? Because we already know what the function f does. It connects x to y. G will connect y to z. Now what will connect x to z? This function is written as like in the previous case, first function to the right side, next function to the left side. This is called g of f, or the composite function of f and g. The composite function of f and g, which will connect set x to set z, right. So this is the nomenclature of this g of f. This is how we write it. There's nothing to know about this in depth. This is how you just name the function of the composite functions between f and g, right. In this we'll look at the intuition under this. So what function f does, it will connect an input x in the set x. This is a simple x here. It will connect to an element in set y. So this is called the image under function f. If you don't remember that, you could refer to the second lecture under function. Now what g does, g will relate any elements in set y, to an element in set z, right. So now f of x is also in the set y, so definitely g will connect f of x to an element in z, right. So look at this argument. Argument is what you put inside this parenthesis. This is the argument. For function f, the argument was x, and you will get output as f of x, right. Now for g, the input is f of x, right. So now the output would be f of x, g of f of x, right, which is written here. So this is how we define the composite function. For a function f which connects x to y and a function g which connects y to z, we can find another function which connects x to z, and this is how we write it. A function f which connects x, set x to set z, right. So this function f is also equivalent to this, right. This is equivalent to, we can also write it as g of f which connects set x to set z. This is easy, right. Okay, we'll go to the next one. So what happens when you select g as the first function and function f as the next function? Now in this case, how do you find a function which relates this set to this set, right? So you can see here that the starting function is g and the second function is f. So you write g first towards the right side, g, then you write f. So this is read as f by g, the composite function f by g. What about this? If you have three functions, the function that connects this to this can be written as h of g of f, or we can read it as h by g by f. Notice this, the first function goes toward the right side, right? This is the right side, and the last function towards the left hand, right? Okay, this is how you write it, and we'll look at some intuition under this now. Okay, now there are certain criteria to be satisfied in order to define a composite function. You cannot just define any composite function, just a composite function for any functions given, be it two functions or three functions. There are certain conditions that have to be met before you define the composite function. So there are scenarios where the composite function exists or does not exist. So sometimes if the function does not exist, we may have to tweak some things so that the function will exist. We'll look into that in couple of slides, right. We'll look at a scenario where the composite function g of f or g by f exists. Now look at this. Function f will relate any element of set x to any element in set y, right. So you know that the function f, there will be a certain range, right, certain range. Now in this example you can see there are 4 elements in set x, and all 4 elements will be connected to 4 elements. Now for this example, for simplicity, I am looking at only one-to-one functions, right. We can generalize this for any one-to-one or many-to-one functions. For all the 4 elements are connected to 4 elements in set y. Now you can see here that function g will connect any element in set y to set x, any element in set y to set x. Now the range of the function f, you can see here that this is the range of the function f. All these elements are included in the set y, right. All these elements are included in the set y. So now you know a function g which will relate any element in set y to set z, right. So you can definitely find a path which relates this input, any input in set x, finally to an output in set z, right. Any output in set z you can relate, because the function f will connect these two, and you can see here the range is inside set y. So you can find any you can find a function, there will be the function is called g, which relates any elements in set y to set z, right. So there will be a problem when there is an element outside of set y, because only these, so here in this example there will be 6 elements, only these 6 elements are connected to set c by the function g, right. other elements will not be connected. So there will be some problems. We will look into them in detail later. Now in this case, you can see here, any element in set X will be connected to set Y, and that element will be taken to any element in set Z. Now we can define a function which will connect set X to set Z, right? Okay, so therefore how do you write a function that connects X to Z? It is written as the composite function g by f, or g of f. So in this case, g of f exists because for any element in X there will be an output in Z, right? So the criteria to be satisfied is this: if the range of the function f is included in the domain of the function g, right? This is the domain. This will be the domain of the function g. If it is a subset, or if it is equal to the domain of the function g, then the composite function g by f exists. Right? This is the intuition, the graphical intuition that you need to understand. So now you know in which cases that the composite function will not exist. Okay, we'll look at this. In this example, you can see here that the set X contains 6 elements A, B, C, D, E, F. Right? The function will connect any element in set X to another set, of course. But in these elements, I have drawn here that A, B, C, and D. A, B, C, and D will be connected to G, H, I, and J respectively. Right? In this set Y, you have 5 elements. Out of 5, 4 elements are connected. 4 elements are connected by the function f. Now, what happens to this E and F? Right? This E and F. E and F will be connected to different elements L and M, which is outside of Y. Right? Which is outside of Y. Now, the function is defined for the set Y and set C, right? The function g is only defined for set Y and set C, but L and M, these two elements are outside of set Y. Now there is no function, the g function will not take L to anywhere, it will only take what is inside Y. So in this case, you cannot find a composite function which connects all the elements in set X. Please note this, all the elements in set X to set Z. It will only connect A, B, C, and D to H, O, P, Q. Right? Only these 4 elements will be connected. Right? So therefore, you cannot find a composite function which will connect all the elements in set X to an output in set Z. Right? Okay. So we'll look at this now. R of f, which means the range of f. In this example, you can see here G is there, H is there, I is there, J is there, K is not there, but L and M. Right? Range of the function f will be G, H, I, J, L, and M. What about the domain of G? Domain of G is defined for set Y. Set Y only includes 5 elements: G, H, I, J, K. G, H, I, J, K. Now you can see here that L and M, these two elements is not contained in the domain of G. They are outside of the domain of G. So we can write it as not an element. This is the symbol for element. This is a symbol for not an element. So L and M are not an element of the domain G. So therefore, what happens? The range of f is not a subset of domain of G, because there will be elements, in this case 2 elements outside of the domain. So the criteria here being that the range of the function f should be included within the domain of the function g, but in this case two outliers will be there. So you cannot find a composite function which connects any element of set x to an element in set y. Therefore g of f or g by f, the composite function, does not exist. You cannot find a composite function for all the elements in set x. But what you can do here, that even though let's say someone insists you to find a composite function which relates set x to set y, he says that I don't care how you do it, by any means necessary, find me a composite function. Now in that case, what you should do is, you can simply redefine the domain x. That means you can take out e and f from the domain. If you can do that, you know that the rest of the elements in domain x, the rest of the elements in this set x will definitely be connected to an element in set z. In that case, you can find a composite function which relates set x to set z, because the problem here being L and M, which comes from these two elements E and F. Right. Okay, this is what I have said earlier. If we redefine the domain of f, that means you can either cut off or add some values, but in this case, generally what we do is we exclude certain elements. In this example, we can exclude E and F. If we exclude E and F, the problem is solved, right? By removing E and F, we can make range of the function f as a subset of domain of G. Right? You can see here, now the remaining elements will be A, B, C and D, and the range of these four elements will be G, H, I and J, and this range is included in the domain of G, right? Domain of G, this is included, so there'll be the connection from from any elements in set Y to set Z. Okay, this is how if you are asked to find a composite function, this is how you should do it. You have to redefine the domain of the first function so that you can find a composite function.